Good morning, student. This is the second class of the production planning and control. Now today we are start with the problem. Okay, the problem that you see, the problem is sequence the following jobs which are assigned as per their arrival by priority rules. In previous class we analyzed about the priority rules. There is the sequencing rules. Okay, now start with this problem. Okay, see, this is a job. These are the job. Okay, you take this A, B, C, D and E. We have jobs, and the time remaining is 8, 3, 7, 9 and 6. And now we have the process time, which is the 7, 4, 5, 2 and 6. So these are the process time. Okay, now applying the rule, if we go through the FCFS, that is the first come first serve, then our sequencing will be A, B, C, D, E. That will be the first come first serve. Which is comes first, that will be first serve. If we go through as per EDD, that is the earliest due date. If we go through EDD, that will be the sequence will be B, E, C, A, D. That will be the sequence. Okay, now if we with the least slack, that is a procedure LS as per least slack. So how we calculate least slack? Least slack is that is the time remaining minus the processing time. That will be the least slack. Okay, so as per the calculation of the least slack, if we take the job A, B, C, D, E, we have get the least slack LS value. There is a 1, -1, 2, 7 and 0. And if you arrange the job according to the LS, the sequence will be this is B, E, A, C, D. That will be the sequence according to the LS. Okay, now we have also SPT and LPT. Through SPT, SPT or LPT you can arrange also. If we go through SPT, the sequence will be D, B, C, E, A, and if we go through LPT, the sequence will be A, E, C, B and D. Okay, so that will be the shortest processing time, one SPT, and longest processing time, that will be the LPT. Okay, so D, B, C, E, A according to SPT, and A, E, C, B, D, that will be the according to LPT. You can arrange any type of works through this sequencing rule. Now one important thing is critical ratio technique. So what is critical ratio technique? What is the lower according to the calculation, if we get the critical ratio, then we can that lower critical ratio given the highest priority. Okay, which one is the lower critical ratio, that will be given the highest priority. Now how we calculate CR, that is critical ratio. Okay, critical ratio is, that is the due date minus the date now divided by LTR, which is the lead time remaining. Okay, so what is CR? That is due date minus this date now, and that will be divided by LTR, which is the lead time remaining. Okay, that will we get the CR, that is the critical ratio. Okay, now how we determine these things? If CR, that is the critical ratio, is less than 1, if it is less than 1, then due date is less than date now. That is the due date is less than date now. So it is behind schedule. The job is running behind schedule. So immediate. So the jobs will be done immediately. Okay. Now if we and second, if we get the critical ratio equals to 1, if we get critical ratio equals to 1, that means that is the due date is equal with the date now. So due date is equals to date now. So that job is on schedule. There will be no slack actually. There will be no slack, and job is on the time and it is on schedule. Okay, and if CR critical ratio is greater than 1, in that case, if it is greater than 1, then we have, that is due date is greater than date now. So if due date is greater than date now, then we have excess time. Okay, so there is some slack also, and we have excess time, so we can get on the job later. Okay, so that will be due date is greater than date now. Now how this calculation actually done? Okay, So this is a problem. Try to understand the problem. That today is the day of 22nd on production control calendar. Okay, and 4 jobs are on order. Okay, A, B, C, D. Then assign the priority rank. Okay, now what are given in the job is given A, B, C, D. There are 4 jobs. Okay, due date in days. Okay, this is the days, that is 28 days, 26 days, 24 days and 30 days, and we have another data of the LTR. Okay, this is remaining. Okay, that are 8, 2, 2 and 12. Now how we assign this job according to the priority rank? Okay, see this is the first we write of the jobs. Okay, these are the jobs. There is A, B, C and D. Now our date calendar is the date now. Which is the date now? That's 22nd is the date now, 22nd. So first if we calculate, that is due date minus the date now. So that will be 28 by minus 22 for first, that will be 6. For second, that will be 26 minus 22, that will be 4. And for third, that will be 24 minus 22, that will be 2. And for the last job D, that will be 30 minus 22, that will be 8. And we can get critical ratio from using all this value. If we this one, that is 6 by 8, we get 0.75. If we get 4 by 2, we get 2. A 2 by 2, this is 1, and we have 8 by 12, that will be equals to 0.66. Now if we arrange according to the sequence, the sequence will be D, A, C, B. That will be the sequence. Okay, D, A, C, B. That will be the final sequence of the job operations. Okay, now you can see another problem. This is also a similar. This is also a similar problem. This is a product passes through 5 stages. Okay, A, B, C, D, E during the process of manufacturing. The stages of work contained, batch size is 100, efficiency, etc. are given. So we have given the stage of A, B, C, D, E. Then we have given the unit work contained 1, 3, 2, 4, 5. Then we have the number of work center, that is 2, 3, 4, 5, 5, and make ready time per batch. Per batch make ready time in hour, we have given in hour, 7.5, 15, 7.5, 10 and 15. Okay, now we need a clear table. What should be the calculate? First, the stage is given A, B, C, D, E. The stage is given. Then the unit work content, that is also given 1, 3, 2, 4 and 5. Then batch work content, this will be calculated. So 100 is the batch size. Here 100 is the batch size. So 100 into 1, that will be 100. 100 into 3, that will be 300, and up to that it is 100 into 5, that will be 500. Now the time per work content in hours. Time per work content in hours. So that will also be calculated. That is 100 divided by 2, we get 50. The 300 by 3, we get 100, and up to that we have lastly 500 by 5, we have 100. Now time per work center. Per work center time, it will be also calculated. Why this thing 50 divided by 0.8? Why we divided by 0.8? Because we have given that the efficiency is 80%. The efficiency, as the efficiency is 80%, we are dividing this thing into by 50 divided by 0.8 and all divided by 0.8. So at the last 100 divided by 0.8. Okay, make ready time per batch, it is given already. We have given here, we have given make ready time per batch. This is we have given 7.5, 15, 7.5, 10 and 15 we have given. So that is the given. And now time, we have to calculate the time for the total operation. And that we will calculate the 70, 140 and up to 140, and this is a total of 530 hours of the total in 530 hours. Now this is how we calculate the time of operation for A. Okay, so for A, so this is time of operation, that divided by 50 divided by 0.8 plus this is the 7.5. So that will be 70 for A, and we can calculate same as for B, C, D and E. So this is the time when we calculate the time of operation. This is the time of operation. We calculate 50 by 0.8 as the efficiency is of 80%, plus this will be 7.5, and that will be 70 for A. And similarly we can calculate for B, for C, for D and for E. The process will be the same. Okay. Now in the second we have come to the situation of line balancing. It is an important concept of line balancing. Okay, so first try to, what is the aims of line balancing? What are the aims? What are the aims of line balancing? Okay, first the allotment of sequential work activity. This is the first thing. Say allotment of sequential work activity is the first thing. Second is to achieve the optimum utilization of your labor. This is an important optimum utilization of your manpower or labor. And second, parallelly, optimum utilization of the equipment which are used in the system. So optimum utilization of equipment is an also is an important thing. And fourthly is which is important, that is the to minimum of the ideal time. So ideal time, minimization of the ideal time, it is also important. Minimization of the ideal time, that is also important here. Okay, now how we calculate the steps in case of when we calculate about the line balancing. When we calculate the line balancing, the first step, okay, step 1, we have to calculate the first, we calculate the cycle time, which is known as commonly known as CT. That is the cycle time. What is cycle time? CT is calculated, that is the available time per period, available time per period, that will be divided by the output units required per period. Okay, so CT is available time per period, and that divided by output units required per period. That is the calculation of CT. That is the cycle time. Okay, so time, as we cycle time calculate, the product after completion leave the production line. It is a normal ruling that the product after completion it will leave the production line. Now in second, we have to calculate the minimum number of worker, that is denoted by capital N. So this is the minimum number of workers, that is N. So how we calculate N? Now, N is equals to this is the total operation time and divided by the cycle time. So how we calculate N? The total operation time divided by cycle time. Then we can get the N, which is the minimum number of workers, that is the N, minimum number of workers. N is equals to total operation time divided by cycle time. So what we get? We get first CT, that is the cycle time, and then we get N, which is the minimum number of worker. Now comes to the third in, that is the group tasks. You have to group all the tasks into appropriate workstation. This is a job. Okay, so group all the tasks which is available tasks into appropriate workstations. Okay, now we have to calculate balancing efficiency, which is EFFB. That is the balancing efficiency, that is EFFB. How we calculate this? The output of task time divided by input by workstation time. So divided by these two, we can get EFFB, that is the balancing efficiency. Now what is output of task time? What is the output of task time? What is this? This is the sum of actual worker times to complete one unit. That is actually the output of task time. Okay, the sum of actual workers time to complete one unit, and that will be calculated by summation of T divided by critical CT cycle time multiplied by the N, that is the minimum number of workers. Okay, so summation T divided by CT multiplied by N, and that will give us the output of task time. Now just enter into the problem. We have a problem here. Okay, this is the assembly activity of 1 to 7 as shown in this in the following. This is the swing. Okay, so this output is 1100 unit per day is scheduled, and this is a schedule for 14 hours. Okay, 14 hours per day operation, 14 hours per day operation. Now we have to calculate the balance efficiency. Okay, so now see this, we have a working, that is a assembly activity of 1 2 3, then it is 4 5, joining of the 6 and 7, and all the time is given. This is 0.7, 0.4 minute, 0.3 minute, this is 0.2, this is 0.5 minutes, 0.4, and this is 0.3 minutes. Now, according to the line balancing process, first is step 1, which is we have to calculate the cycle time, CT. So, what is CT? So, CT is, this is available time divided by the output unit required per period. Okay, so that is the cycle time, CT, that is the available time, and divided by output units required per period. Okay, now what is the available time? This is the 14 hours is the schedule per day, 14 hours. So available time is 14 multiplied by 60 as it converted into hours. Okay, so 14 into 60, so divided by the output units required per day. We have already given the output of 1100 unit per day. So it will be divided by 1100, and that gives we have the 0.76 minute. We have an answer. We have a cycle time of 0.76 minute. Now this is the step 2. What do you calculate? This is the minimum number of workers, which is that the capital N. That is the minimum number of worker. Okay, N. So what is N? N is the, previously we have already told that total operation time divided by cycle time. So how we get total operation time? So add all these things, all the time given from 1, 2, 3, 4, 5, 6 and 7, joining all the time, add up all the time gives you the total operation time. So start from 0.7 plus 0.4, 0.3 up to plus 0.3. Okay, so this gives the total operation time. Now this will be divided by cycle time, which we previously calculated. There is the cycle time is 0.76. So total operation time, this should be divided by 0.76, which is the cycle time. Now we get the 3.68. This value, the 3.68 the value. Okay, now actually we are calculating the workers, so the answer might not be in the point fraction. So actual number of workstation will be 4. There's a 3.68 is not the answer. It will be normalized as 4. Okay, 4. So there are, so we get that there are 4 workstations. Okay, now the third step is you have to group all the tasks into the 4 workstation. As we have here the 4 workstation, you get the workstation number 4. So group all your tasks into 4 workstation. You have to group the 4 workstations. Okay, now this is the actually the grouping pattern. Okay, this is the grouping. Okay, now how we group? Activity 1 is first, then you group activity 2 and 3, then activity 4 and 5, and then activity 6 and 7. So we have here 4 groups: group A, group B, group C and group D. In group A we have activity 1, in group B we have activity 2 and 3, in group C we have activity 4 and 5, and in group D we have activity 6 and 7. Now the calculation of the ideal time as follows. We can get every ideal time to be calculated for group 1, for group B, for group C and for group D. For group A, this would be 0.76 minus 0.7, that would be 0.06 minute. Okay, now for group C, for group B, this is also 0.06 minutes, for group C 0.06 minute, and for group D this will be 0.06 minute. Now we have to calculate the total ideal time, which is the total ideal time. So that, so 0.06 into 4, because we have 4 groups, 1, 2, 3 and 4. So we have 4 groups, so total ideal time will be 0.06 multiplied by 4, and that will be 0.26 minute. That will be our total ideal time. Now what will be the cycle time? Then total cycle time, that will be the time 2.8, which is calculated previously, plus this is the ideal time 2.24 minute. Okay, so adding these two things over 3.04 minute is the total cycle time. So total cycle time will be 3.04 minute. Okay, now in the final sequence of calculating the balance efficiency, as per the balance CFF balance, we can simply calculate the summation of T divided by cycle time into N multiplied by N. Then we can get The 2.8, this is divided by 4, this will we have a multiplied by 0.76. So finally we can get a percentage of 92.1 percentage. That will be the efficiency. So if balance efficiency of the system is 92.1, okay, you can get it through another process. It is operation time divided by total cycle time. That will also give you the balance efficiency percentage. Okay, EFFB you can calculate either through this process or through this. This will be operation time divided by total cycle time. You can easily calculate the 90. This will be 92.1. Okay, so similarly this process, similarly you can see the another there is another problem. Okay, this is an assembling of a work from A to H, available of in 4 workstations. So workstation is given 4. Then calculate the ideal time and balance efficiency. We have here A for 2 hours, then B this is 1.3 hours, then 5.6 hours C, then we have D 2.5, E 7 hours, we have F 2 hours, then joining of H which is also in 2 hours, and then G here is also the 3 hours. So this is the a pattern. This is all assembling of work of A to H, and it is available in 4 workstations. Now we have to calculate the ideal time and also the balancing efficiency. Okay, now firstly, as we done previous, we have to calculate the in first step we have to calculate CT. Okay, sorry, the CT. Okay, that is the total operation time divided by the number of workstations. That will be the CT. So joining all the times, okay, 2 to 1.3 all the time joining, and divided by the number of workstation. As the number of workstation is 4 already given, 4, so divided all things by 4, so we can get 6.35 hours as CT. So CT is 6.35 hours. Now in step 2, what is the group your tasks according to the group your tasks. So now we activity 1 2 3 4 we have here grouping like this, that is ABD. This is one line job, it is in 1, then C in 2, E in 3, and FGH in 4. This is okay. So we can calculate the time of all the groups, 5.8, 5.6, 7 hours and 7 hours. Then we can, in same process, we can calculate the ideal time. For first this is 0.55, for second there is 0.75, and the 3/4 it is 0. Okay, now we can also calculate the total ideal time, also calculated. Ideal time is these are the 0, so ideal times means 0.55 plus 0.75, these two will be the ideal point, and total ideal time will be 1.3 hours. The joining of these two, the summation of these two is 1.3. Okay, now ideal time is already done. So now we have in step 3, that is we have to calculate the balancing efficiency or EFFB, that is operation time divided by cycle time. Through this formula we can easily get the balancing efficiency of a 95.13 percentage. I mean, you can say that balance efficiency is 9.95%. Okay, now from this, if you have operation time and if you have ideal time, then joining of these two you can get the total cycle time easily. That is 25.4 our original time of operation already we get from here. This is the time of operation 25.4, and we have idle time, which is the 1.3. okay, so joining with this 25.4 and 1.3 we can get the 26.7, which is the total cycle time. Okay, so these are the actually the process of calculating of the total ideal time, total cycle time, and we have an important calculation, that is the balancing efficiency of any system. So first assemble your jobs. It is important, you have to assemble all the jobs point, it is important. Okay, so allotment in first we have see in the first, that is the allotment of the sequential work activity. It is an important job. Then the cycle time you have to calculate the minimum number of worker. It is also important, because two main goal or aim of line balancing is you have to optimize the process which can utilize optimum to achieve the optimum utilization of labor. It is very important, and also the optimum utilization of your equipment. Okay, these are the two to measure work. First one is the optimum utilization of labor, and second one is the optimum utilization of equipment. These are two very important. And then in process, you have all organizations have to try to minimize their ideal time, which is important. They have to minimize their ideal time. Okay, that is important. So this is the second class. Okay. Then in we have end here. This is the second class up to this line balancing. Okay, so in we have in PPC, production planning and control. So in the next day we are on the another topic regarding in PPC. Okay.